Hi, this is Algebra 1, Lesson 67. We're starting on page 271. We're going to talk about a review of equivalent equations and elimination. Equivalent equations have the same solution, so their solution sets must be equal sets. So, for example, the number 2 is a solution for both x plus 4 equals 6 and x squared minus 4 equals 0. If we plug 2 in for x here, we get 2 plus 4 equals 6. 6 equals 6, so this is true. If we plug 2 in here, we get 2 squared minus 4 equals 0. 4 minus 4 equals 0, which is true. But these equations are not equivalent because there is another solution to this equation that is not a solution to this equation. It is true that x equals 2 goes into both of these, but into this equation you can also say x equals 2 or x equals negative 2. So let's try x equals negative 2 into both of these. We do negative 2 squared minus 4 equals 0. This equals 4. 4 minus 4 equals 0. So this is still true. But if we plug it into here, we get negative 2 plus 4 equals 6. Negative 2 plus 4 is 2. And this says 2 equals 6, which is false. So these two are not equivalent equations because the set of possible solutions to both equations are not equal. If we start with an equation and we multiply every term in the equation by the same number, then the resulting equation is equivalent to the original one. So here we have x plus 2 equals 6, and let's try multiplying every term times 2. So we're going to multiply all the terms on this side by 2 and this side by 2. So we'll get 2x plus 2y equals 12. So if the ordered pair 4, 2 is a solution for the first equation, then it's also going to be a solution for the second one. So let's try it. We have x plus 2 equals 6. If x equals 4 and y equals, that's x plus y equals 6. So if x equals 4 and y equals 2, then this is 4 plus 2 equals 6, which is true. Okay, let's try it into this one. We have 2 times 4 plus 2 times 2 equals 12. 8 plus 4 equals 12, and that's true. Okay, now we're going to talk about elimination. So far, we've been using substitution to solve equation sets like this. Today, we're going to learn another method, the elimination or addition method. If there's an ordered pair that solves both of these equations, then they are equivalent equations, and we can add an equal quantity to both sides. So if 5x minus 2 equals 4, then we can add the 5x minus 2 to one side and 4 to the other side. Let me show you what I mean. If these two are equivalent equations, and that's what we're trying to find out, then we should be able to add them together. 2y minus 2y is going to cancel, which will leave us with 6x equals 12. And now we can solve for x. X is going to equal 2. And now we're going to use this to solve for y in both equations to make sure they match. So we're going to plug this into here. We get 2 plus 2y equals 8. Subtract 2 from both sides. And we get 2y equals 6. So y equals 3. Okay? Now let's plug this x into the other equation. So we have 5 times 2 minus 2y equals 4. 10 minus 2y equals 4. Subtract 10 from both sides. Minus 2y equals minus 6. Divide by negative 2, sorry. And we have y equals 3. The y's checked in both sides, so our ordered pair is 2 and 3. Solve by using the elimination method. If we just add these together, as is, we're going to get 5x plus 3y equals 16, which frankly is not very helpful. We haven't eliminated any of the variables, and this is not a more helpful equation than either of those two were. So let's look at the original equations again. If we multiply equation A times 4 on both sides, then we'll have a negative 4y. And then we can use the elimination method, add the equations together, and the y's will cancel. Okay? So let's take 2x minus y equals 13 and multiply both sides times 4, which is going to equal 8x minus 4y equals 52. Okay? And now we're going to add this equation to it. 3x plus 4y equals 3. Okay, and now we're just adding 11x, negative 4y and positive 4y, so those cancel, equals 55. Divide both sides by 11, and x equals 5. Now we're going to plug this 5 into both of the original equations and solve for the y. So we have 2 times 5 minus y equals 13. 10 minus y equals 13. Minus y equals 3, so y equals negative 3. Okay, let's plug the 5 into the other equation. We have 3 times 5 plus 4y equals 3. 15 plus 4y equals 3. Minus 15, minus 15. 4y equals negative 12. Divide by 4. And y equals negative 3. Okay, so our ordered pair is 5 and negative 3. So let's try this one. Solve using the elimination method. There are no convenient ways to solve either of these in just one step. We can't multiply 3 times something to make 2. We can't multiply 4 times something to make 3. So we're going to have to multiply both equations to find a lowest common multiple. We could do it with either x or y. Let's do it with y this time. So the lowest common multiple of 2 and 3 is 6. We're going to want one of them to be a positive 6 and one of them to be a negative 6 so they cancel. So let's multiply a by 3 and b times negative 2. So this will be a positive 6, this will be a negative 6, and they will all cancel. So we're going to start by going 3 times 2x minus 3y equals 3 times 5. Right? We're multiplying both sides. And this one we're going to multiply times negative 2. 3x plus 4y equals negative 2 times negative 18. Okay? So here we have 6x minus 9y, which equals 15. This one we're going to have negative 6x minus 8y equals, those two cancel, 36. Okay, now we can add these together. So we have 6x minus 9y equals 15, and minus 6x minus 8y equals 36. And now we'll add these together. Those cancel. Negative 17y equals 51. Divide by negative 17. And y equals negative 3. Okay, now we're going to plug this negative 3 into both equations to make sure that the x's are equal. So we have 2x minus 3 times negative 3 equals 5. And 3x plus 4 times negative 3 equals negative 18. So this is 2x minus, sorry, this was really sloppy, negative 9 equals 5. Those cancel, so we have 2x plus 9 equals 5. Move the 9's over there. 2x equals negative 4, so x equals negative 2. Okay, let's try that over here. 3x plus minus 12 equals negative 18. We're going to add 12 to both sides. 3x equals negative 6. Divide by 3. And x equals negative 2. So the ordered pair that fits both of these will be negative 2 and negative 3. Okay, just for fun, let's do the same example, but this time we're going to solve for y. This one's already a negative and this one's a positive, so we don't need to multiply, we don't need to make that work. We just need to find the lowest common multiple. In this case, it will be 12. So we're going to multiply the top equation times 4 and the bottom equation times 3. So we have 4 times 2x minus 3y equals 5 times 4. And we have 3 times 3x plus 4y equals negative 18 times 3. Okay, multiply this through. This is 8x minus 12y equals 20. And this is 9x plus 12y equals negative 54. Okay, now we're going to add these together. So we have 8x minus 12y equals 20. And 9x plus 12y equals negative 54. So this is 17x, the y's cancel, equals negative 34. Divide by 17 and x equals negative 2. Right, now we're going to substitute the negative 2 into both equations and solve for y. So we have 2 times negative 2 minus 3y equals 5. And 3 times negative 2 plus 4y equals negative 18. Minus 4 minus 3y equals 5. Add 4 to both sides. Negative 3y equals 9. Divide by negative 3. And y equals negative 3. Okay, let's solve this one. We have negative 6 plus 4y equals negative 18. Add 6 to both sides. 4y equals negative 12. Divide by 4. and y equals negative 3. So our ordered pair for these two equations is negative 2 and negative 3. That's where these two equations will cross if we graph them. Okay, let's try one more. There's once again no really pretty place to start with these, so we're going to start with the y. The 4y is negative already. So the lowest common multiple for 5 and 4 is 20. So we're going to multiply the top one times 4 and the bottom one times 5. So we have 2x plus 5y equals negative 7. We're going to multiply this one times 4. And we have 3x minus 4y equals 1. We're going to multiply this one times 5. Those are parentheses, not absolute zero signs. Alright, multiply through. We have 8x plus 20y equals negative 28. We have 15x minus 20y equals 5. Now we'll add these together. 8x plus 20y equals negative 28 plus 15x minus 20y equals 5. Okay, we have 23x, the y's cancel, equals negative 23. Divide both sides by 23. And x equals negative 1. Okay, now we're going to substitute this negative 1 into both equations to solve for y. So we have 2 times negative 1 plus 5y equals negative 7. And we have 3 times negative 1 minus 4y equals 1. This is negative 2 plus 5y equals negative 7. Add 2 to both sides. 5y equals negative 5. Divide by 5, and y equals negative 1. Let's try that on this side. We have negative 3 minus 4y equals 1. Add 3 to both sides. Minus 4y equals 4. Divide by negative 4. And y equals negative 1. So our ordered pair is negative 1 and negative 1. Okay? Sorry, I'm running off the bottom of the page. Okay, that's it for that lesson. Try your practice problems and let me know if you have any questions. Thank you.